Hello, friends. Happy Friday. I am so excited to teach this lesson to you, even though I'm not actually there. So, to start with, I want you guys to think back. Yesterday, we talked about comparing decimals, right? And we did it when they all had the same place, right? We were like thousands, thousands, thousands. And we compared and talked about how we look at decimals from the left to the right, right? We start on the left and we move to the right to compare them because which place value has the most value? That's right, the tenths. So we're going to jump right into this, and we're going to do it today where they have differing place values. So you got to get your books out, and we're going to go to page 106 and 107. Okay, so 3.9, 106 and 107. Go, go, go. Okay, so hopefully you're there in 5, 4, 3, 2, 1. Awesome. So you have made it to your book. Go ahead and take a look at this slide here. So I'm going to read this to you as you read it with me. Here we go. Two friends are playing a game. They each pick up a card and then compare the decimal fraction they chose. The decimal fraction on Cherie's card has 2 decimal places. The decimal fraction on Oscar's card only has 1 decimal place. Oscar thinks he holds the greater decimal fraction. Is this possible? Go ahead and pause and discuss with the sub or Miss Ismail. So, what did you guys say? Do you think that it's possible? Well, let's keep going. Let's go ahead and try it out, right? So if somebody has 2 decimal places on their card, they have 2 decimal places on their card, then they have something that goes to the 100th place, right? The 100th place. So let's say, for discussion's sake, we have on the first card 0 and 39 hundredths. Okay, and I'm going to go ahead and color those in on my grid. Yeah, what do you say? Let's do it. All right, so it's 39 hundredths. So first I'm going to color in my tenths. How many tenths do we got? Well, that's 3. 1, 2, 3. Okay, and then 9 hundredths. So we're going to color in 9 squares. I'm going to just do X's. 2, 3, 4, 5, 6, 7, 8. 9. Awesome. All right. Now, on Cherie's card, she had 39 hundredths. But on Oscar's card, he had, 6 tenths. So even though his number only has 1 digit after the decimal and Cherie's number has 2, who has the bigger number? Well, let's go ahead and color in Oscar's to see if our graph here can help us out. I guess it is kind of like a graph, but I should call it a model. Our model here. Let's see if our model here can help us out. 2, 3, 4, 5, 6. 6 tenths. Remember, each row is a tenth, right? All right. So, who of these 2 friends has more colored in on their model? Go ahead and discuss and pause the video. Okay, well, I couldn't hear that discussion, but I'm hoping that you guys came to the conclusion that Oscar's number is bigger despite the fact that it has less digits. The number of digits doesn't determine how big it is, right, friends? It's the place value that determines how big a number is, especially when we're talking about decimals. So, let's keep going. All right, so Cherie and Oscar are still playing this game. I mean, they must really like this game. So this time, Cherie picks a card with only 1 decimal place, and Oscar picks a card with 3 decimal places, and they think that the 2 decimal fractions represent the same number. Is that possible? What do you think? Go ahead and discuss with a partner. Okay, so if you think it is possible, go ahead and raise your hand, and if you think it's not possible, keep your hand down. Okay, looks like we have a mixed group, so let's find out. So this time we got one with 1 decimal place and one with 3. So let's say, again, we're going to just go with the flow here. Oscar's card had 3 decimal places, so we'll say he had 0 and 400 thousandths. 400 thousandths, okay? And Cherie had 4 tenths. Are these 2 numbers the same? Are these 2 decimal fractions the same? Well, let's find out. So, I guess we're going to start with Cherie's because she's going to be easier to color, at least at first, right? So she has 4 tenths. Now remind me, a tenth, is that going to be a box or a row? I mean a column. That's right, it's going to be a column, right? So we're going to color in 4 columns. We got 1, 2, 3, 4. 4 columns. All right. Now, to color in 400 thousandths, I'm going to zoom in a bit. I'm going to remind myself. So each row is a tenth, right? Each column is a tenth. But then each box in the column is a hundredth, right? And there are 10 of those boxes in the tenth. Then inside each of those boxes are 10 thousandths, right? So we have 10 thousandths, 20 thousandths, 30 thousandths. So like each box has 10 of them. So if I have 10 if I have 10 little thousandths boxes within each hundredth box, right? I have 10 in each hundredth box. So I'm going to write that down. I have 10, 20. How many am I going to have in the total column? 30, 40. Make your guesses while I'm doing this. 50, 60, 70, 80, 90. That's right, 100. 10 times 10, right, friends? So we have 100 thousandths in each tenth. I have 100 thousandths in each tenth. So I'm going to take that knowledge and I'm going to use my knowledge of area to help me color in 400 thousandths really fast, right? So if I know that going this way, I have 100. And I need to have a total of 400. How many columns am I going to have to do? I have to do 1 column. How many? 1 column, 2 columns will give me 200. 3 columns will give me 300. 4 columns will give me 400, right? 4 times 100 is 400. So if I have 100 in each column, I'm going to color in 4 columns to get 400. So I got 1, 2, 3, 4. 400. Well, wait a second. Didn't I color in 4 columns for Shuri? I did. These 2 numbers are the same. What? I know. It's crazy. I know. They don't even look alike, right? You're like 4 tenths is not 400, but it's 400 thousandths, right, friends? So remember that we have no additional hundredths in this number and we have no additional thousandths. There are zeros in those other 2 place values. So they're adding no additional value to the number. They're just representing it in a different way. So we have the same value, 4 tenths. We're just showing it through the thousandths place. Very cool, very cool. All right, so let's compare these 2 numbers then. Now that we know that the number of place values is not the only thing that determines our value of our number, right? It's not the let me rephrase that. The number of digits does not determine our value, but the place value determines our value. So these 2 numbers, we got 43 hundredths and 399 thousandths. Wow, which one's going to be bigger? Well, friends, we just colored in a model. So this time I'm going to show you a more efficient strategy. Are you ready? All right. So when I'm comparing 2 decimal fractions, when I'm comparing any 2 numbers really, the first thing I'm going to do is I'm going to line them up place value wise. I'm going to line up the place values and then I'm going to take it from the biggest place value and I'm going to compare them, that one, and then I'm going to work my way to the right. And the reason I'm going to do that, do you guys remember? What happens to our place value as we move to the right? Does it get bigger or smaller? It gets smaller, right, friends? So as we go to the right, we are making our number smaller. So we are going to start on the left and work our way to the right. But first, before I can do anything, I have to line them up, right, friends? All right, so how do I make sure our place values are lined up with decimal fractions? Does anybody have a guess? Hopefully somebody thought that we should line up the decimals. Because remember, friends, what does the decimal show us? The decimal shows us where the ones place is. That's right. All right, so let's do it. All right, here we go. We're going to line up our ones places. So I'm going to go on top of 399. I'm going to write 0 and 43 hundredths. There we go. All right. So we're going to start on the left and work our way to the right. We're going to start on the left. All right, so do either of these numbers have anything in the ones place on that left side of that decimal? Nope, you're right. No, 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 no. They have no value there. That's a 0. So they're the same. So we're going to have to go to the next one. What's our next place value? The tenths. That's right, the tenths. So we're going to look. The top number has a 4. The bottom number has a 3. So which one is bigger, top or bottom? The top. The top is bigger because it has a 4. So therefore, this entire number is bigger than 399 thousandths. 43 hundredths is bigger than 399 thousandths. Boom, shakalaka laka. Amazing, friends. Now, another way to think about this, real quick, before we move on. Oop, that's not what I meant to do. Before we move on, we got to talk about this. The other way you can do it, instead of just lining them up, is you can add placeholders to help you. So, for example, right? Remember how we talked about with our 400 thousandths was equal to 4 tenths? Because those zeros in that hundredths and thousandths place didn't change the value. It just changed how we looked at the number. That's all you have to do here as well. If you would like to make it easier for you yourself to see, you can say, well, I know I can put a 0 in this thousandths place because it doesn't add any value to the number, but it helps me see it. It helps me see what this number would look like if it went to the thousandths place. So 43 hundredths is equal to 430 thousandths. And I can put that 0 there to help me see how it's bigger than 399 thousandths. That's just another strategy. If that didn't make sense to you, friends, don't do it. Okay, great. All right, good talk. So they had us with the model again, but like I said, we don't need to do that. Okay, another strategy, just one more strategy real quick, is to put it on a number line. And we talked about this yesterday. The first thing we're going to do when we have a blank number like this is we're going to mark our halfway point, right? We're going to mark it. We're going to say, oh, that's 5 tenths. Right in between 0 and 1, 5 tenths. Yep, that's right, friends. Then you're going to take it and you should mark your other tenths, right, to make it a little bit easier for yourself. So you could be like, okay, so like 1 tenth, 2 tenths, 3 tenths, 4 tenths. That was not very well spaced out. And then we go 6 tenths, 7 tenths, 8 tenths, 9 tenths. That was much better. Good job, Cinderella. Thank you. So 0 and 1 tenth, 0 and 2 tenths, 0 and 3 tenths, 0 and 4 tenths. Okay, we're going to go all the way up. All right, so where do these places, these numbers fall on this number line? Well, we have 43 hundredths. How many tenths does that one have? That's right, it has 4. So it's going to come before or after the 4 on the number line. It's going to come after, right, friends? Because it has not just the 4 tenths, but some hundredths too. We got some more value on that. It's not just 4 tenths, it's 4 tenths and 3 hundredths. So it's going to go a little bit past the 4. We'll say that one's that one. All right, great. What about 399 thousandths? How many tenths does that one have? Well, it has 3, right? It has 3. So that one is going to go before the 4, right? Because it does not make it all the way to 4 tenths. It comes before it. That's right. So we can see even on here that 43 hundredths falls farther down the number line. All right, guys. Excellent work. So at this point, you're going to open you already have your math books open, hopefully. You're going to go ahead and you're going to do pages 106 and 107 in your workbooks, okay? Do the whole step up and the step ahead. That's not optional. I'm not sure where you guys got the idea that that's optional, but it's not. So go ahead, do those 2 pages, and if you finish early, you can work on your must-do, may-do list. All right, and I'll see you guys on Monday. Have a great rest of your day. Please listen to Mrs. Mail. Okay, bye.